Problem number 1. This is also double angle problem. It is saying a line AB 90 millimeter long is inclined at 30 degree to HB. So first of all, here true length is 90 millimeter. Theta is 30 degree. End, po End point A is 12 millimeter above the HV and 20 millimeter in front of VP. So HA is 12 and DA is 20. Now its front view measures 65 millimeter. Front view means the final front view. So we can denote it as something like that. It will be 65 millimeter. Actually this is final front view, so it is A dash B dash. So now we are going to draw our 2D projection XY line, and it is first angle projection, so H will be above and D will be below. So this is our 12, this is A dash, and this is 20 millimeter, and this is A point. So now they have given 30 degree angle and true length is 90 millimeter. So what we will do, we will make an angle 30 degree and we will place our 90 millimeter over here and we will get our B1 dash point. Let me pass the locus line. This is locus line of V in front view. So now we have to place our final front view length, that is 65 millimeter. So how we are going to do it? We got our locus line over here, and if we take center A dash and length or radius will be 65 millimeter, and we will make an arc which will cut this locus line somewhere here. And if we join this one, this is B dash, and if we join this one, this is our final front view length. This is 65. Now we are going to draw our top view. We will simply extend this first let me draw the locus line of A in top view. We will simply extend this point. We don't know how much we have to extend, but we do know how much we have to extend this line from B1 dash. This will be our B1 point. Now what we are going to do to get the B2 point, what we are going to do, B2 or B point, will make center A and radius will be AB1, and we will make a arc like that, which will cut this extended line somewhere here, and this point will be your B point. This is B dash, this will be B. So this is your final top view length. For true length, what we will do, again we will take center as A and radius will be, okay, let me draw this locus line. If we make center A and radius is 90 millimeter, it will cut somewhere here, and this length is our 90 millimeter. This point is B2. So we got all this angle right now. This is 30 degree, that is theta. This will be what? Your alpha. Alpha, if you measure, it will be 44 degree. Phi will be 45 degree and beta will be 54 degree. Now next problem. A line AB 90 millimeter long is inclined at 45 degree to HP and its top view makes an angle 60 degree with VP. So true length is 90 millimeter. Again theta is 45 degree, and here it is saying top view makes an angle 60 degree. So you can see from here also top view is making angle with VP, that is beta is 60 degree. One end A is in HP, that means HA is 0 and 12 millimeter in front of VP, so DA is 12. So now let me draw our 2D projection. So here we will be getting our A dash point and 12 millimeter from here we get A point. Now it is saying theta is 45 degree and that is 90 millimeter. True length is 90 millimeter. So we'll make an angle with 90 millimeter. This is what we get, B1 dash point, and this angle is 45 degree. After that, okay, first let me draw this locus point. Locus B in front view, this is locus A in top view. So we know the angle but we don't know the length, so we are going to just draw 60 degree. Beta is 60 degree, but we don't know, we will leave like that. Length we don't know, so we will leave like that. First, as we got this B1 point, B1 dash point, we will easily get B1 point. How we are going to get? We will just extend it up to our top view locus line A and we get our B1 point. Now A as a center and AB as a radius, we will make an arc. which will be cutting this line, this angle somewhere, and we got our B point. So now we got our final top view. After that, we will extend this B point up to this locus point of top view. We get B dash point. Now our true length. Okay, now let me join this one. This is our final front view, and this is our final top view. Now for here, for true length, what we will do, we'll make a center A and 90 millimeter. Okay, let me pass locus A in top view. Now if we make A as a center and 90 millimeter, our length, somewhere it will cut here, and this point will be our B2 point. So this is 90 millimeter. Now we can get our alpha angle. Beta we know, that is 60 degree, theta we know, and another angle is phi. Phi will be around 38 degree. Alpha will be 63 degree. Now our third problem. A line CD 90 millimeter long measures 72 millimeter in front view and 65 millimeter in top view. This means it is saying it has CD has to be inclined on both plane, HP and VP. So true length is how much? 90 millimeter. Front view length is 72 millimeter and top view length is 65 millimeter. Draw the two views of the line if it fully lies in first quadrant. Obviously it will be lying in first quadrant. Find the inclination of the line. Assume point C is 25 millimeter, sorry, I wrote it wrong, 25 millimeter above HP and 20 millimeter in front of VP. So we got our HC 25 and DC is 20. We are going to draw our 2D projection. This is our HC 25. This is going to be C dash, and this is 20 millimeter. This is C. Now we got our front view length and top view length. So front view length we got, we will simply draw a parallel line with XY line here and another parallel line over here. This is our D2 dash, and this means this is 72 millimeter and this is 65 millimeter. This will be our D1. Now since we don't know any angle, what we will do, we will just extend this point. We don't know how much we have to extend, just extend that one here also D1 point, just extend. After extending this two line, we'll make C dash as a center with 90 millimeter radius. We will draw an arc which will cut this line somewhere, and that point will be our D1 dash. This is 90 millimeter. Same goes for here also. 90 millimeter long, C as a center, will cut somewhere here, and this length is 90 millimeter, and this will be our D2 point. For getting final front view length, we'll make C dash as a center and C dash D2 dash as a radius. We will cut this locus point. This is locus of, for here, D point, and we will join this line, and we got our D dash. This is the final true length. Same goes for here also. C as a center, and C D1 as a radius, which will pass this locus point here. If we join this, we got our, this is D, CD. So this is our final top view length, final top view length. And now we will measure this angle. This is theta, this is alpha. Alpha is 60 degree, it will be 60 degree, we will get 60 degree, and theta will be 44 degree. Phi is 37 degree, and beta is 56 degree. Now another problem. Top view of a 75 millimeter long line measures 65 millimeter, while the length of its front view measures 50 millimeter. So true length is 75 millimeter, top view length is 65, and front view length is 50. Its one end A is in HP. So HA is 0 and 12 millimeter in front of VP. So DA is 12. Basically this problem is same as above. So first we will draw our XY line. HA is 0, so HA dash point is here on XY line, and A point is 12 millimeter apart of it. Now we know top view length and front view length. So front view length is 50. So here our this line will be our A1 dash B2 dash. This is 50 millimeter. Then if we draw another parallel line, and this will be our B1 point, and this is 65 millimeter. Now again we are going to do extend this line. We don't know the length of it. After that, what we will do, we will make A dash as a center and 75 millimeter radius. It will cut this line somewhere here, and this point will be B1 dash. This is 75. Same goes for here also. It will cut some point, that is B2 point. This is also 75. Here radius is 75 and A is center. It will cut and the point will be B2. After that, what we will do, okay, first we will draw the locus of front view and top view B point. Then make our radius A dash B2 dash and center is A dash, which will cut this locus line over here, and this will be our B dash point, and this length is our final. True length. Here also same thing, A as a center, AB1 as a radius, and it will cut this locus point somewhere here, and if we join this point, this is AB. And we can back check it. If this B1 dash and B is in same line, this problem is correct. After that, what we are going to do, we will get the angle, we will measure this angle theta. It will be measured as 30 degree. Alpha is 48 degree. Phi is 48 degree. Beta is 59 degree. A line AB 65 mm long has its end A 20 mm above HP and 25 mm in front of VP. So true length is 65 and HA is 20, DA is 25. The end B is 40 mm above HP and 65 mm in front of VP. So HB is 40, DB is 65. They didn't give any angle, so we will just draw XY line, and we know A dash and A point. This will be from XY line to A dash point is how much? That is our 20 mm, and this is 25 mm. Since we don't know any angle of it, but we do know HB and DB length. So what we'll do, we will just draw locus line first. This will be 40 mm HB, and DB is 65 mm. So obviously this will be, we will get our B dash, and here we will get somewhere B. We will just draw the locus line first for point B, top view, and okay, locus of B, top view, locus of B and front view. Now what we will do, we know true length. If we make A dash as a center and 65 radius, it will cut this locus line somewhere here, and this will be our B1 dash point. And this is 65. Same goes for here also. This point will be our B2 point. So if we extend this point up to this locus line of A in top view, we will get B1 point. Same goes for here also. If we extend this line, we will get this is locus of A in front view. We will get B2 dash point. So now what we will do, we will make A as a center and AB1 as a radius, and which will intersect somewhere here, and we will get our B point, and this is our final true length at top view. Same goes for here also. Again, A dash as a center and A dash and B2 dash as a radius, we will get point B dash, and this is our final true length. So now we can measure our angle. This is theta, it will be 18 degree, alpha that is 23 degree, theta 38 degree, and beta 40 degree.